involving thousands of cells and hundreds of drugs. These are now preclinical experiments typically done across dozens or hundreds of genotypes, and the goal, as you'll see in a moment, is often to then associate features of those cells, most simply genetic features, with overall drug sensitivity in an attempt to predict what would actually be efficacious ultimately in humans. And so there's a sense of what this data would look like. And the idea is that a better drug in a dose-response curve like this would lie on the left, and a worse drug would lie on the right, and there's going to be some line that's drawn in here, and that line is then going to be the line of sensitivity. Even though this is a continuous distribution, as you'll see, we like to sort these into binary variables, and it's really on this basis that contemporary efficacy-oriented pharmacogenomics has been done in oncology. And there are a series of websites you can go to, and areas where you can actually look and see what would be predictors across different types of disease. So really this is the data set that we started to look at a couple of years ago. And a postdoc in my lab, Mohammed Falahi, who's now a professor in Michigan, said, well, you know, it's worth considering that there's more going on in these data than somehow the notion that there is a sensitive and insensitive population. And in particular, if you go back to just a classic sigmoidal fit, so think back, you know, James Black, 1950s, you'll be able to distinguish a couple of features of any such curve. One of them is indeed the midpoint of the response, the IC50 or the EC50. Then there's sort of the maximum degree of the response, so the extent to which, in this case, for example, the population is killed at the highest achievable drug dose, and then there's going to be some slope relationship between them. And so you can sort of think of these three different parameters here, and I've sort of put them up with their degree of variability, so the theory would say there's going to be some variation with regard to the midpoint of the response, some variation in maximum effect, some variation in the slope. And so you can ask yourself, with a little naive searching around on PubMed, which of these is popular? And you would see, not even distinguishing in this case for oncology, that there is an overwhelming preponderance of focus on the midpoint of response. So the idea, which I will now call potency. So the notion is that the potency of the drug is the only distinguishing characteristic, let's say, across a pharmacological series that's going to be the figure of merit, and that's the thing we score in different cell lines, et cetera. We're not going to really worry about the maximum effect or this slope thing, whatever they are. So when we actually went through and sorted the data, and you've not intended to read this in any great detail, so this is now taking the targets. This is about 60 drugs for which we looked at a large-scale data set, and we actually asked what is the degree of variability in each of these three parameters. What you will see is it's essentially equivalent. And by mutual information, you can see that they're equally explanatory of the resulting curves. That is to say that there is as much variation in the maximum effect or in the slope of that relationship as there is in IC50. And as I've said before, really these latter two parameters have been entirely ignored. And you can simply see that in a data set here, and I pop up here the paper that you can go back to that's now getting a series of updates with additional data that will soon appear in public databases. So here are simply two drugs, and you can see both of these are inhibiting aspects of the PI3 kinase signaling cascade. And you can see that they certainly differ with respect to IC50, but they also differ with respect to the slope characteristic. So the question that we asked ourselves is what actually might be the underlying basis of this type of difference? And so the, there's a little movie in here that may or may not play. And so when we actually went back and actually looked at some of the underlying biology, what you're looking here in blue actually is a uniform population of cells, so a single clone in which we've engineered in a reporter that will change from blue to yellow as that cell undergoes apoptosis. And we've actually treated it here with an investigational drug and also natural ligand. And what you could see in that movie was that cells were dying at different times. And if you were actually to look across the dish, you would see, regardless of dose, about 20% of those cells would survive. And that's shown in those two plots there where we're looking in that distribution at the time of death and the probability of cells surviving overall. And what's interesting for this study, and essentially any study of this type you can conduct in either in vitro and to a lesser extent in a mouse, is that you can get that surviving population isolated as shown here at the top of the slide, regrow those cells up into a complete population, repeat the experiment, and get exactly the same phenomenon over and over again. So what that convinces you is this sense of a fractional response in these populations is in fact a stable property of these populations, and the degree to which it's fractional or not would vary with drug